Okay, hi everyone. Welcome back to another lecture in AutoGIS. Let's start in 1 minute. Maybe still a few will join us. In the meantime, you can write here on the presemo as usual if you have some comment, questions from last week. Yeah, so I see already there are a few comments about the exercise from last week, kind of contradicting, but that's how it usually is. So, yeah, so someone thinks that exercise 2, problem 3 is not so clear, intuitive, but that's a good comment, so we can review it for next year. Yeah, and the other two comments are saying that exercise 2 is a bit more fun and more clear, and that's nice to hear. Well, things get more interesting because at first we just cover the basics and then we start doing actual GIS, and I guess that's the main motivation for most of you. So things become a bit more practical and interesting. Yeah, I saw on Discord that there was a lot of confusion around the AutoGrader. Yeah, I already wrote you on Discord that we do not grade purely based on the AutoGrader. So if you think AutoGrader has done a poor job giving you a grade, don't worry, because we go through all the responses. The main idea of this auto-grading is to give you immediate feedback, so it hopefully helps you a bit like finish the exercise. But good to know that there were like problems with it, so we can improve it for next year. Yeah, okay, so I guess we can start. There are no big questions right now. So as usual, let's open CSC Notebook if you haven't done so already. And let's pull the latest changes from GitHub. So I have done it already. So go to the folder where you have the lessons usually. And then from GitHub, you can pull the latest changes. And once you do it, you should see a new folder, lesson 3, and you have for a data folder as usual, and for Jupyter Lab notebook file. Have you all done this? Okay, good. So we can get started, but let's start from the course's website. Yeah, so as I said, things are starting to get even more interesting. Like I particularly like this lecture quite a lot. I think it's very fun, and it's a very useful thing. We try to make the whole course useful, but this is particularly interesting and probably relevant to a lot of things you will be doing. So, yeah, so what we will be doing today is to work with geocoding. This is a very common GIS practice. So imagine you have a file. So you have some data file where you have addresses from different kinds of places. It can be like home locations or places for businesses, and you want to import it to your GIS. So in order to do that, you need to have coordinates. So that's what we do with geocoding. So of course, you can, well, in ArcGIS it's a bit tricky, and in QGIS, there are some plugins to do this, but of course in Python it's more fun, and then you have more freedom how to do things. So we will learn how to do geocoding first in the first part of our lecture today. And then we will work a little bit with, and not a little bit, we will work quite a lot with spatial queries. So questions such as, is a point inside a polygon, or do two lines touch or intersect with each other? So we try to see how we can do this using GeoPandas library. So again, we will continue working with GeoPandas library and learn learn more of its functionalities. Another useful thing that we will get to practice a bit today, well, you have done joining tables already with pandas, so we will do that a bit today. And also we will perform spatial join, which is quite useful. So if you're doing some GIS, very often you need to do something like that. So joining different data files based on the location of your features. So that's something that we will be practicing today. Yeah, so a bit of overview of the geocoding. So I already told you what is the general idea of geocoding. Luckily nowadays there are a lot of quite many service providers that can help us geocode addresses so we can get coordinates. So this is a list of some of them. If you Google, if you search a bit more, you might find even more. Well, as you can see, these are like some of them are open source, so you can do quite a lot for free, but they come usually with limitations. For example, the quota you have, how many queries you can make to the API. So there are some limitations with that. Some of them are commercial. So as you can imagine, Esri ArcGIS doesn't do things for free. So you can buy quota and do things. But yeah, there are quite a few options. So if you have a small data set like the one that we are going to practice with today, you can use many of these services which are free. Yeah, so there are different options and there are different libraries for doing that. We use one library that is kind of, well, it is included in GeoPandas, so we are going to work with GeoPy. That is included in GeoPandas, so we don't have to import anything. Well, there are different ways of doing things, but the one that we are going to try today is OpenStreetMap Nominatim. That well, it's a good tool. It works based on OpenStreetMap. It's open source, so it's a nice thing to practice. But another additional benefit of using this for this course in this exercise, in this lecture, is that with many of these services you need to use the API, and for that you have to obtain some API key. So you have to take a few steps to do that. With this one, you don't need to do that, and it's free. So it makes things a bit smoother for our lecture today. Yeah, so that's what we are going to work with in today's lecture. So now we go to our Jupyter Lab environment and we start geocoding using GeoPandas. Yeah, so as I said, well, you have seen already that GeoPandas is one high-level library that builds upon a lot of like lower-level libraries. So one of the libraries that is included in GeoPandas as a package is GeoPy, that gives us a number of functionalities, and one of them is this function called geocode that allows us to geocode addresses and get the coordinates for them. So what you have to provide to the tool is a list or a pandas series of one column in your data where you have the addresses, and we will see how it works. So as usual, let's start by setting our path to the data. We have practiced this already a couple of times. So run, the code is already there, so let's just run it. So the data file that we are going to work with is a file called addresses.txt. So it's a CSV file. It's separated with semicolon. So this is something I've done many times already. We are using the pandas library to import our data. So the code is already written there. We don't have to type again. So let's just run this cell. So now the data should be loaded. Let's have a look at our data to see what it looks like. As usual, we use addresses.head. So this is what our data looks like. The import has been successful, so all looks good. So we have the index column, we have some field called ID, and then we have this column called ADDR, short for address, that has a number of addresses in Helsinki. Yeah, so as I said, this is a free tool, so it comes with certain limitations. So one of the limitations is that this Nominatim tool that we are going to work with is a service provider. So the limitation is that you can make only one request per second. So if you have a huge file with thousands of points, thousands of like rows in your data, you can imagine it will take quite a while to run. But in our case, the data is not so big, so it should be enough. So let's get started and see how this works. If you remember last week when we were importing GeoPandas, we got that warning. That doesn't affect our work, but if you don't want to see it, you can just use this cell, run this cell, so we shouldn't see that warning anymore. And then we can start by writing our code. As always, we import the library that we need for our work, which is, again, GeoPandas. So let's quickly look at the functions documentation. Okay, the link is broken. I will fix it later. Okay, let's just start writing and then I will explain why we're doing it. So we will create a new variable and let's call it geocoded addresses. Then we use the function that for importing, for geocoding the addresses, and it's under tools. So it's geopandas.tools.geocode. So there are a number of parameters that you need to pass to this function so it can give you the output. So one thing that you definitely need to provide to the function is the name of the column. You should give the column where you have the addresses stored. So in our case, it's a column name. Well, it's a geoseries, so it is in our data, so addresses. And if you remember, the name of the column that we are going to use it was something like this. So this is the first parameter that we need to, well, the order doesn't matter because we are giving the name, but anyway, this is one parameter that we need to provide. So the column in form of list or geoseries where we have the addresses. The second thing that is required is the name of the provider. As I said, there are different providers that can take care of the job of geocoding. We are going to try Nominatim, so let's write its name. So the provider is Nominatim, and we pass it in as a string. So these are the two variables these two parameters are required by the geocode function. Depending on what service provider you're using, there might be need for other parameters. For example, now we are using Nominatim, and for Nominatim you also need to specify as user agent, so just some name for yourself who is making this query. So you can just put whatever name you want. The name of the parameter is user_agent. So I'm going to write AutoGIS 2023, but you write something else, so we are not all using the same. So you can just write some name, whatever name you want, and you can pass it in as a string. Okay, another good thing that, to add here, is not required, but it's recommended to use it, is a timeout parameter. So this is usually by default defined by the service provider you're using. So if you make a request and it takes unusually long, you don't want your code to be just running forever and waiting. So you should specify some timeout time. So for example, if you couldn't get the coordinates for a certain address within 5 seconds, just give up. So you can continue with your code. With nominatim, if you don't provide anything, I think the default value is 1 second, which is quite short depending on how much load there is. Like for example, now we are a class. If you all run it at the same time, probably it's gonna take more than 1 second to give us the result. So it's good to put a longer timeout time. So let's try with 10 seconds, and this is how you define it. So timeout equals 10. So this should give us the coordinates. Let's also add the the first 5 rows of our data after we do the work to see if everything looks all right. So geocoded addresses that head. So let's run this cell. Okay, so now you can see the 10 seconds timeout was probably too short because many of us are doing it. Did anyone get the output? Or did you all get the same error?
Still running.
It's still running. So I'm gonna try my luck with 20 seconds to see if it works. Did anyone get the outputs yet? As you can see, this takes a while because we are giving it 30 seconds for each row in your data, so it takes longer. It's usually faster now. Probably server is busy or something.
I think for me the 10 seconds worked out. At least I got the output.
Okay, great. So someone has succeeded at least. Has anyone else gotten the output? Okay. Yeah.
So now there's the provider, and then now we wrote the nominative, which is the. So what is that now?
So it's a service provider. Yeah.
Yeah, so you always have to write it just that way, so it can recognize it from the geocode.
Yeah. Yeah. If you check
Do
the
you always have to call it as a provider, or can you just name it as whatever, and then when you, like now, we wrote that it's the nominative, it always recognizes that the nominative is the.
yeah. Yeah. So this, well, you cannot change this word. Provider is the parameter, is a function. So provider is the exactly how they have defined it. So it has to be provider.
Yes.
And then there is a list of providers that are included in this library. So if you check out the documentations, there is a long list.
Okay.
Many of the ones that I actually showed you here, you can just use them on the first page. So you just write their name, then it knows where to get the data from. So, yeah. And then each of the service providers might have different requirements. In case of Nominatim, we only needed to put a user agent, but if you're using another provider, you might need to provide other parameters. But you can check it in their documentation. So I got the output as well. So did everyone get their output? Yeah. Okay, great. So it took longer because we had to wait a bit more, up to 30 seconds. So you can see that now we got the coordinates. So what we had originally was just these addresses. Now the address field is updated from OSM. For example, you can see here you didn't have the name of the area or neighborhood. Now, for example, it says it's in Ruoholahti. So it's getting the addresses from OSM, so it has been updated. And you have a new field called geometry. So now what we have gotten as the output is a geodata frame, which is great. So we can do GIS with it using GeoPandas. Okay, so now we want to try one more thing. Now that we have gotten our output and we have stored it in a separate variable, so we named it geocoded addresses. So now we want to join this new table with the first table we had, which was, I guess, called addresses or something, addresses. So we want to join the two. So we learned how to do this. One way of doing this we practiced in the first period was with Python, with a pandas library. So if you have a common field between two tables, you can just use it. But in this case, we can make it even easier because it's the same, the order of the rows are the same because we use the table to generate some output to get the geocoded, get the coordinates. So the two tables have the same order of the rows. So instead of checking for a common value, we can just join them based on the indices. So let's see how that works. So let's create a new variable to store our join table, and we will call it geocoded addresses with ID. Yeah, so I also put the name of the variable there so we get the output, so we can look at the output. So what we did now, we had two tables. One was these geocoded addresses that we got from Nominatim, and then we had these addresses. It was the first file that we imported, so we just joined them. This is something I've done many times in Pandas and in GIS, in QGIS, ArcGIS. So you can just see that they have, now Python added the fields from the second table to the first one. So this is what we had from Nominatim, from OSM, geometry, and address. Then ID and ADDR came from the other table. So the joining worked. Well, you can guess what is the type of the output, but just let's test it. So what is the type of the output we have here? I just pasted the name of the variable so I don't have to type it again. So we had a geometry field, so it's not a surprise that the output is a geodata frame. So one thing to pay attention to here is that when you are doing the join, this geocoded addresses, this was a geodata frame. So we had a geometry field there. And then we added some table, which was just a data frame. We didn't have coordinates there. So when you do the joining in this order, so if you join this to this one, and this one is a geodata frame, the output will be a geodata frame. But if you do the opposite, so if you join a table to a geodata frame, then the output will be just a Panda data frame. So in this case, this had a geometry field. So it just added columns from this one to this one, and it is still a geodata frame. So if you do the opposite, you will get the data frame. Okay, this is something that this file that we just produced, we are going to work with it in the rest of the lecture. So let's save it so we don't lose our work. The code is already there. Let's just run it. Yeah. Okay, so that was fairly easy. So you just need to know, if you want to do this, see how big your data is, then go check different service providers in the documentation and see which one suits your needs. Like, do you have to pay for any of them, or like how big your data can be and how fast it is. Okay, now let's continue. Next, we are going to talk about point in polygon queries. Yeah, so this is something that, well, now we are going to work with point in polygon, but of course the same logic applies if you want to check if a line is inside a polygon. We are going to see different examples. So there are different ways of doing this. You know that there are different algorithms to see, well, if you just look at your data, if you visualize, it's easy to see if a point inside a polygon or not. But if you want to make a computer understand that, then you need to come up with some kind of algorithm. So some kind of test that the computer goes through and then can figure out whether it's inside the polygon or not. So this is something, if you want to just play with it, it can be also one idea for your final assignment if you want to do something like that. But there are different algorithms for doing that. For example, there is this, here we have put this ray casting algorithm, which just counts the so it counts the number of times. So if you have a polygon like this, and then you have a point, if you just shoot a line from this, if it's inside the polygon, it's just gonna intersect with the polygon once. But if it is somewhere outside, then it's just gonna, so based on the number of odd or even intersection is going to give you the result, whether it's inside or outside. So there are different algorithms you can develop and like just if you want. But the good news here is that in GeoPandas we have already ready functions to test this, so you don't have to define it. So, and these come from Shapely. So Shapely is the library that we worked with in the first lecture. So in GeoPandas we are benefiting from Shapely's functionalities. So Shapely has a lot of functions that help you figure out, for example, whether a polygon is, whether a point is within a polygon or a polygon contains a point. So we are going to try this too now. So let's just, before we start working with GeoPandas, let's do it on a more like lower level, working with Shapely. So let's import Shapely.geometry. Geometry. That code is already there, so you don't have to type it in. And we are going to create 2 points. like we did on the first lecture and exercise. Let's also define a polygon using Shapely. Let's print our points and polygons to make sure everything is all right. It looks okay. So now if we want to check if our point is within the polygon, you can just simply write. So I want to see if point 1 is within the polygon. So it's going to give you a Boolean output, so it's either true or false. In our case, it's true, meaning that yes, point 1 is within the polygon. So these are called predicates, so they show the topological relationship between different kinds of geometries. So we will see some of them today, and there's a longer list of them that you can check on the documentation of Shapely. Let's try the same thing with point 2. Let's see if point 2 is within our polygon. The output is false, meaning that the point is not inside the polygon. So we can do the same thing the opposite way. So these predicates are very intuitive. So like, is point 1 within this polygon? Or you can say the opposite. Does this polygon contain point 1? So it's very intuitive. So, and they do the same thing, it's just the opposite. So you might be wondering why we have both of them. There can be cases where if you use one of them, it might be a bit easier than the other one. So imagine sometimes you have a lot of points and you want to check if the points are inside a polygon, then you probably write a for loop. Then it's easier if you use within. So you go through each of your points and then you check if it is within the polygon. There might be an opposite scenario in which you have many polygons and you want to check if those polygons include that point. So then you write a for loop, you go through each of your polygons, then you check if it contains that point. So depending on what you're using it for, one of them might be easier. That's why both options are available to us. Yeah, so let's try this contain as well. So let's see if our polygon contains point 1. True, so our polygon contains point 1, which is not surprising. We had tested it before with the within function. Let's try it for point 2. Polygon contains point 2, and this is false. So point 2 is not inside our polygon. Okay, so as I said many times already, Shapely is lower level library. Now we want to try to do this with GeoPandas without specifically using Shapely, but we know where the functionality is coming from. So let's define our file path again. The code is already there. And then we import GeoPandas. Again, this piece of code is here if you don't want to see that warning. So what we are now importing is Helsinki city districts. So it's a bunch of polygons that we will look at soon. So it looks like this. You can see the name of different districts in city of Helsinki that we are going to work with. Let's take a look and see what our data looks like. So city underscore districts dot plot. Yeah, so as you can guess, This is from Helsinki, and these are the polygons for different districts. So now this is a bit like more realistic situation. Probably you have done like work like this in GIS before. You have a bunch of points and you want to see if those points are in the southern district of Helsinki. So this is something we are going to try now. Yeah, so we have a bunch of polygons here for different districts, but we want to just keep one of them, which is the southern district, so this Eteläinen. So let's import our data again. Well, not import, let's just get rid of the rest of the polygons here. So we just save it in a new variable called southern district. And the southern districts so we get it from our city districts, but only when the name is Eteläinen. So city underline districts dot name equals Eteläinen. Yeah, so now we got rid of the rest of the districts in Helsinki. We are only keeping the southern one. Now we are going to use the addresses that we had geocoded previously. So we want to check which of the points we geocoded in the first part of the lesson today is actually within this district. So let's get our data. We have already saved it, so it should be easy to get it. Let's store it in addresses. So we use GeoPanda's read file. Why do I have this? And it was saved in our data directory. And we had named it addresses. And the format was GPKG. Okay, so now we are using the file that we had created earlier. So now we are going to practice something that is a bit new. So now we are going to create a plot to see how our data looks like. So we load the districts. We also will add the points to the data. So we are going to later work more with cartography and making maps, but this is just one example of how things work. So let's create our visualization. We have done done something similar before. So we create the axis, and we create a plot of the city districts in Helsinki. So here we are going to provide a face color. So with the polygon, you can imagine face color is the infill color of the polygon. And we are going to use the default color for the outline, but if you want to change it, for that you have to provide a value for edge color. So now we just put the face color and we want it to be gray. So if you check the documentations, we will work with the visualization later, but if you check documentations, there's a list of colors that are built in. So if you just write gray, it should know what it should look like. And then we are going to add more features to our map. So we want to now highlight the southern district. So we basically add a new layer with a different color to our map. So we had named our file, our variable southern district. We are going to add it to the same map, so we use the same axis. And the face color, which is the infill color of the polygon, let's put it red. Let's also add our points to the map. So addresses, that was the variable name we had used for importing. Then we plot it and we add it to the same axis. So for points, you can just put color. You don't need to write face color anymore. So the color of the point. And again, if you want to specify outline, you can put edge color. But we go with the default. We just put the infill color to blue. And then you can also specify the marker size or the size of the point on your map. So marker size 5. So if you don't have any typos, this should work. Yeah, we had typo. Yeah, so this is the map. So this was one practice of how creating a map with multiple layers in Pandas, in Python. Yeah, so we can see that some of our points are within this highlighted area of southern Helsinki. Some of them are not. So what we are going to do is just extract the points that are within within this polygon. So let's write addresses. That within. So we are going to check if it is within. So something that we did with Shapely, we can do it similarly with GeoPandas. So addresses dot within. Then the southern district is the name of a variable we had used for storing the southern district of Helsinki. We have only one row in our data. Let's exactly point to that geometry in that one point. And I will tell you shortly why that is important. Yeah, so now that we did this through GeoPandas, we can get it for all the points in our addresses data. So the output, you can see it's some array with Boolean values. So it just tells you whether that particular point is within southern district polygon of Helsinki or not. So before in Pandas, we had seen that you can put conditions and filter out points based on a condition, the rows in your data. So you can see that what this function returned us is a Boolean value. So it's basically same as a conditional statement. So you remember in Pandas, you could get all the rows that, for example, have a certain value, a value more than 5 in one of their columns. So this is basically the same thing. It's a statement, a conditional statement with true-false output. So we can use it to extract some of our data based on this condition. So let's see how we can do that. Addresses in the southern district. So we name our new variable addresses in southern district. So it's going to get the points from addresses, the file that we had created in the first part of the exercise, and it checks with the within condition. So if it checks that yeah, Southern District, then let's just copy and paste this to see what our data looks like. Yeah, so what this is basically doing, it goes through your data that you stored in addresses. It goes row by row and it checks for this condition to see if it is within this polygon or not. So this is just the code we used earlier to check if it is within the polygon or not. And it's going to return Boolean value. So if it is false, it won't be included. If it is true, it will be included. So yeah.
We need build at and the physical and geometry of the
Yeah, so if you don't do this, if you just put the whole data frame there, what it's going to by default do, it goes row by row. So if you have many rows in your polygon and you have many rows in your point, so if you don't specify one polygon, it's going to check row 1 with row 1, row 2 with row 2, row 3 with row 3. Now we just had one polygon, it's the Helsinki Southern area, so we don't want that to happen. So by default it will just do it row-wise. So if you if you have just one polygon and you want it to be done for all the rows, then you have to specifically point to that geometry in that particular polygon.
But we only have one row in the Etelä and the Southern.
Yeah, but it doesn't know.
Okay.
Yeah, it doesn't know. So it would just probably just check it, the first one with the first one, then it stopped because there's no matching. But this way it knows that, okay, it will just do it for all of the rows in your point data. Yeah. Okay, so now let's try to visualize our point. Let's add a cell here. It's missing from here. Okay, let's add a cell and let's visualize our points. So we create a new axis and we put city underline districts dot plot. And put a face color gray for it. So we are pretty much repeating what we had done earlier. So you can also copy from earlier. Then we have Southern District plot. And we add it to the same axis. And we put a face color of red. So now we use the points that we just did the filter on. We add those to the map. So it was called addresses in the Southern District. So I'm just going to copy that long name so I don't have to type it. dot plot. Then we add it to the same map, so axis is the same. Let's put whatever color you want. I'm going to use gold. And then we specify the size of the marker. Marker size equal 5. Okay, so now we created our new map. As you can see, we got rid of all the points which were not within the southern district of Helsinki. Okay, do you have any questions from here? Is everything clear? If all is clear here, let's move on to the next file, which is intersect. This is a bit shorter. So now we are going to work with lines. So we will define two lines using Shapely. Then we will test if the two lines intersect or touch each other. So do you remember from like other courses you have done in GIS, what is the difference between touch and intersect when it comes to topological relationships? Yeah, so basically intersect is a bit less picky. So if there is any kind of overlap between your features, it means they are intersecting. But with touch, there shouldn't be any overlap. So it's just if it is polygons, it's just the boundary of them touching them. Or if it is a line, it's just the end of the lines touching each other. So basically with intersect, it's less picky as long as they are just touching each other. Doesn't matter how, if they're overlapping or not, it's true. But with touching, it's a bit different. But now we see an example of this. So if you don't remember, maybe you will remember after this. So we are going to import shapely.geometry, and we are going to define two lines called line 1 and line 2. So let's test if line 1 intersects with line 2, and it's quite easy to do. Line 1 dot intersects line 2, and again the output is Boolean, meaning that, well, it's true. So line 1 is intersecting with line 2. Let's see if line 1 is touching line 2. This is also true. So line 1 is touching line 2. So now we want to visualize the two lines to see how they look like actually. So one easy way of doing this in our case here is just define a multi-line string using them both, so we can just visualize them at the same time. So these are the two lines we have, and as you can see, the two lines are touching, so they have one common node. So this is what touching is. Yeah, so as I said, they should be just touching each other. So for example, if you check if line 1 touches itself, what do you think the outcome would be?
False.
Yeah, it will be false because they're overlapping. It's the line with itself, so they're just overlapping. So it should be false. But let's test. So line 1 touches line 1. Yeah, you see the output is false. So if they're overlapping, they are not touching. But they are probably intersecting. But let's test that. So line 1 that intersects line 1. And this one is true. So intersect is a bit less picky in how they come into contact. So just whichever you're using in your work, remember that the outputs are different. So remember what it is and which one you should use. Yeah, so if you don't have any question from intersect, let's continue to special join. So do you remember doing a special join in like QGIS, ArcGIS? Do you remember any examples of where you have needed it before? Can someone give some example? Yeah.
Yeah, when you had to join data sets that were intersecting each other for one polygon.
Yeah, exactly.
Yeah, I don't know, I worked with airport data and I basically had a list where it was listed which airports fly to which airport, and then but it was just like an Excel file without any coordinates, and I had a list where all the airports were stored as a point file, and then I just joined them, basically.
Okay. Yeah, great. So you know what we are trying to achieve here. So we have a few examples here. One of the things we will try, and this is a very common thing to do, again, depending on what you're doing. Like in my work, I've used it a lot. You have like points, and you want to see what is the population around it. And you know, in Finland, from Statistics Finland, we have this grid-based population data that you can just download from Python. So it's a very common practice. You just do a special join between points and the grid to get the population for each of the locations. So this is one example we are going to work on now. Yeah, so let's get started. So these are some of the conditions that we already saw. We worked with contain, intersect, within, touch. So these are the ones that we have in GeoPandas. In Shapely, we have a few more, but these are pretty much all the things we need most of the time in GIS. So these are the predicates that we are going to use when doing a special join. So these are a few important terms here to remember when you're working with special join, because it significantly affects the output. So there is when you're doing special join, which we will start doing very shortly, you have to define a parameter called, well, you should say if it is left, right, or inner, and it affects the output significantly. So if you specify it as left, so you can think of two tables. So one is on the left, one is on the right. So if you specify left, it will keep all the records from the left data frame with empty values if no match. So the main thing is the one on the left. So if there is no matching data on the right data frame, it will just put empty values for it. So it will keep all the rows in your left data, and it will keep the geometry of the left data frame you had, the geodata frame. If you specify it as right, as you can guess from the name, it will keep all the rows in your right data. And if on the left one there is one missing match, it will just put empty values for it. So it keeps all the rows in your right data, and it will keep the geometry of the right column, right data, the geometry column of the right data. And then we have another type, which is inner. So it only keeps the records that are matching. So if you do a special join between some points and those grids of population you have in Finland, for example, the example I just said, it only keeps the grids and the points that have they match. So if there is one point that is outside the boundary of like the grids, it will be just excluded from the output. And it will keep the left geometry column. So now we get started, and this should make more sense. But this is something that you have seen, even if you haven't specifically used this word, you have seen this a lot when working in ArcGIS or QGIS. So when you're doing a join, you can choose if it will keep all the rows or only matching ones, for example. But these are just the words we use here. But the concept shouldn't be new to you. So let's first define the path, as usual. to our data. And then we are going to import GeoPandas again. So if you don't want to see that annoying warning, uncomment the first 2 lines. So what we are going to do is now get some data from, we are going to get population data from WFS. We saw an example of this last week. So it's getting the data from an online source. So we saw this syntax before. I was testing this earlier and there was some SSL, this HTTPS certificate with the problem with the website. Let's first try it with like this. If it didn't work, we will uncomment this part. So this is basically saying that, okay, I trust the website. You have seen that when you open a website on your browser, it complains that certificate is not valid or something. So same thing is happening here. We're just saying, okay, we trust the website, go ahead, get the data. So one thing to remember, if you're getting your data from WFS, you should specify your coordinate system explicitly. So it doesn't know by default what is the coordinate system. So you know the coordinate system from the metadata of your data. So wherever you have gotten your data from, I don't know, Statistics Finland or somewhere, they have said that data comes in this coordinate. So you should just explicitly say that what the coordinate system is. So let's run this to see if we get any errors. Yeah, so we got some error about the certificate of the website. So let's go and uncomment these 2 lines of code here. So we import some library that helps us handle the certificate, import SSL, and then there's that 1 line of code that says just trust the website, basically. So let's run it again to see if we get the output this time. Okay. No errors this time, so everything should be okay. Did it work for all of you? Okay, good. So let's take a look at our data to see what we just imported. So population, so we named it what? Population underscore grid. I will just copy the name from here. And I will use head function to take a quick look at our data. So this is how the data looks like. If you have worked with it before, probably it's familiar to you. So the data has many columns. We just want to use some of them. So let's get rid of the ones we don't need. So we just need the population and the geometry. So we don't need all the age-specific population counts and those. So let's just get rid of those. So population grid equals so these are the 2 columns that you want to keep. Now, of course, geometry, that's what we're going to work with. And then we are going to change the name of the column to English so it's easier for all of us. So population grid equals, and remember, you probably remember, for renaming a column we needed to pass a dictionary with the new value, the old and new name. So this was the old name. And this will be the new name. So we change it to population. Okay, so now it should be done. If you're not sure, you can test it with head, but we should have gotten rid of the columns that we didn't need and also translated one of the column names. So now we want to calculate something. This is again something we do a lot in GIS. Like for example in ArcGIS you have this, this field calculator or something like that to calculate something. So now we are going to do it the Python way. So we have the population for in each of the grid. What we want to get out of it is the population density. So what we are going to do is divide population by the area of the grid in square kilometers. So the grids are 1,000 by 1,000 meters. So we are going to calculate this for square kilometers. So this is how we can do this. So this is an example of how we can calculate things. And of course you have seen this before in pandas. GeoPandas is not very different. So population grid. So the new column we are going to create, let's call it population density. And for calculating that, we just read the value of the population. This is from the field that we just renamed to English, so we called it population. So we just read the value from there. And then we divide it by the area. So we know how to get the area, population underline grid. This should give us the area, and we want it in square kilometers. So we are dividing it by million to get it in square kilometers. So you notice these underscores. You don't have to put them, but very often when the numbers are long, when you have too many zeros, it's common to put some kind of divider to make it easier to read. In Python, you can put underscore. So if you have many digits, if you have a lot of zeros, you can put underscore to make it readable for yourself. So Python knows that it's not really a value there, so it won't cause any problem. Let's also print the head to see if everything is done well. Underline grid, that head. Probably have a typo here. Okay, so now we just calculated the population density. So we had the population, we just divided it by area in square kilometers. So this is the population density. So one important thing when we are working with join, special join, the two geodata frames you're working with should have a matching coordinate system. So this is not always a problem if you just use it in ArcGIS or QGIS. It just takes care of it, kind of, without you seeing. But in here, it won't happen like that. So you have to, if the two data frames are not in the same coordinate system, you have to change it so they're matching. So let's test if our coordinate systems are the same before we do the join, the special join. And one way of doing that is using assert, which we have used before many times. So we want to see if the coordinate system of addresses.crs addresses equals population grids CRS. And if it's not, then it's just gonna tell us that CRS are not identical. Yeah, so the coordinate systems are not identical, so we have to do conversion here. So we have to change the coordinate system, and this is something we practiced last week, so should be fairly easy. So let's change the coordinate system of the population grid. Yeah, so we learned this last week, so we don't need to specifically say what coordinate system to use, so we just use addresses.crs, so the coordinate system of the CRS data, the coordinate system of the addresses data. So let's just run this and do the conversion. So now the coordinate systems are the same, so now we can actually do the special join. So yeah, so this is how you do a special join. Let's create a new variable, and we are going to call it addresses with population data. So we had the points that we geocoded in the first part of today's lecture. Now we are going to especially join it with the population grid to get the population around each of these points. So addresses with population data. Addresses, so this is the syntax you use for doing a special join, so it's just s join. So we are going to join our addresses with population grid, so we write the name population grid. Then this is the parameter we were talking about earlier. You should say how. Then you should specify whether it should be left, right, or inner. So this is your left data frame. And then you have your right data frame. So you have addresses as your left, and then population grid as your right data frame. I guess, for example, in ArcGIS, this is called like target data or something when you're doing a special join. And then you have to specify what predicate you're going to use. So based on what you're doing the special join. So in many GIS software, it's just a drop-down list you choose from. Here you have to specify it. So we are going to use within. So we are going to, we want to just see if the point is inside the grid cell or not. So, but you can use anything depending on your need. And let's just print the head of the data to see if it looks okay. I will copy the name of our variable so I don't have to type it again. That head. Okay, so if you are doing this for the first time, you probably do not get this kind of error, but since I have tried this before, I'm getting an error. It's basically, if you look at the traceback, it's a long one, but basically it's saying that, well, these are reserved names, so the geodata frame you're working with should not have any columns that is named index left or index right. Yeah, so since I've done this before, these columns exist in my data, so I'm going to fix this, but let's double check that this is actually the problem. So let's add a new cell. If I look at, I want to see which of the data frames has the problem. So let's look at population grid first. See if this is the sort of the problem, and we can see that it's not, so we don't have any fields called index or anything like that. So the other geodata frame you are using in our join is addresses. Let's check that one out. So addresses. So now you can see that yes, this is the source of the problem. So since I've done this before, we already have a column named index, right, that is causing this error. So if you do this, if you encounter this problem, if you have done this several times, it's easy to solve. So you just have to get rid of this column here. So that's easy to do. So let's just add a new cell. So let's just create a new variable. Let's just overwrite the variable we had, addresses, and it will be addresses dot drop. Then here we put the name of the column that we want to drop, and it is index underscore right. And we just specify that this is a column we want to remove and not a row, and we run this. So let's check one more time to see if it was removed. Yeah, so we don't have that field called index right anymore. And now if we run this special join again, it works fine. So you probably got this output with the head. You see the data looks okay. So you did the join, and now you have this newly added. So we have, this is the file we created initially in the first part of the lecture. So we had the addresses, we geocoded them, and now we should see also this population density added. So this is what we did using this special join. So now we are going to visualize this to see how it looks like. So this is, again, we will get back to the topic of visualization later, but let's do a bit of practice. So this is how we can create a map. So we are going to create a thematic map, and we are going to apply graduated color. So we are going to apply color based on the population field we calculated. So this is the syntax. Do we have it already typed in here or not? No. So maybe you can just type as I'm explaining, or just copy it from the course's website. So we create a new plot based on this data that we just created after joining. We specify the size of the figure. You specify based on which column you want to create the visualization. So what we are going to create, apply the colors based on is population density field, which we just calculated, and we added it to our data by joining, by doing the special join. Then you can specify color maps. So there are a bunch of colors built in. So if you just write reds, you can check in the documentation here. There are a number of colors that are built in. So this is a list of colors. So if you just put grays, purples, blues, reds, so it will just create shades of that color, which is quite easy to use. Then if you remember in any GIS software, when you're creating a map, based on a certain value, you need to specify how you want to classify the values. So here you are going to use quantiles, but there are different ways of doing this, as you already know. So these are the methods that are available to you for classifying the values. So you can use quantiles, you can use equal interval, or you can use natural breaks or Jenks classification method that we have seen in GIS software. Then you specify the marker size that we have already seen. Then if you set the variable legend as true, it will create a legend for you. We will go through details of how to improve maps later on when we talk about cartography, but now this should be enough for our purpose. And then let's also add a title to our data, to our map. Population density around address points. And then if you run the code, you should see something like this. So now you have visualized the points, and the colors are applied gradually based on the population density field. Let me know if you manage to run this and get the output. So you can basically do this you can use the same visualization for different kinds of maps. So we never actually looked at the grid data that we work with, but if you want to see how it looks like, if you haven't seen it before, you can just basically use the same code. I guess it's already there, you can just run it or just copy and paste it. The only thing we change here is the data that we are visualizing. So population grid. So if you just run the code, this shows you the population grid from Helsinki, which we just used for this special join. Yeah, and if you want to keep the data at the end, remember to save your file. Yeah, do you have any questions from a special join? And these are quite intuitive, and you will understand them even better after you do your exercises. So how was the workload of the exercise last week? Because in the first week I remember there were a few comments that it was too much. Do you think last week it was more balanced? That's good. So I don't think it should be a problem this week either. And the exercises are basically what we just did today. So you're going to practice with geocoding and special join. So I said already last week that we only had the auto-grader for the first 2 weeks. So there is no auto-grader this time. So if you push and you don't get any feedback, it's okay. We don't have the auto-grader here. Yeah, and part of the reason is that, well, it's under development, and the other reason is that with these exercises you have a bit more freedom. You know, with AutoGrader you have to do things a bit in a certain way, so it works. So now you have a bit more freedom. You can do things a bit differently, and it shouldn't affect your grade. So yeah, so you have 3 exercises. Let's go through them. The deadline, as usual, is by the end of next Thursday. And since we don't have the AutoGrader now, we do the grading here, so similar to first period for those of you who were in the GeoPython course. So there won't be a pull request now. In the first 2 exercises we had that pull request, that's where you got the grade. Now it's just in this MD file in your repository. You will see it. There's a part here where you see who has graded you and your grade and some feedback. So similar to GeoPython now. So let's take a very quick look at the exercises. So something similar to what we did, just the data is different. We have some shopping centers, so you want to basically see how many people live around those shopping centers. So we are going to work with similar data. Yeah, so you just import the data, you do a special join. You geocode the data because you have addresses for shopping centers, and then you save it. In the second part, you create some buffers. There are hints telling you how to create buffers. And then you save the file you just created after buffering. And then the fun part is at the end where you do the special join. So you use the grid data, the one that we just worked with. And if you use WFS, you can use offline file if you just download it and use it, or if you use WFS like we did, remember that if you got that SSL error, just add that piece of code so you can continue. And that's pretty much it. Yeah. Thank you very much. If you don't have any questions, we can conclude here.
Thank you.